Hi friends, it's Kamal and you're watching Maths by Jajoria. Please don't forget to subscribe my channel. In this video, I will explain differentiating when you have x to the power n. So where n is the any number. So you can use the definition of derivative to find an expression for the derivative of x to the power n, where n is any number. Is called differentiation. Now, in my last two videos, I should say. So in my last two videos, I've been explaining about the differentiation, different methods. However, in this one, we'll go with a few more where you have to find the expression for the derivative of x to the power n. Okay. Now, for all real values of n and for a constant a. Okay, so let's say if you have fx equal to x to the power n, then you have derivative of this represent like this, where you will write down so the derivative, what would that would be? So derivative of f, so you can also say first derivative, so that would be your n x n minus 1. Okay, so please pay attention to this. It's very important. You have to memorize this. If you have anything like this, all you need to do, you bring the n in front of that when you do the differentiation, and then the value of n will minus 1. Okay, so x to the power n minus 1. However, n comes in first here as well. Okay, so this is for all real values of n. Okay, we will talk about constant as well later on. Yes, so let's do step by step first. If now again, I'll say to you, if y equal to x to the power n, then okay, then you don't write like this here, okay, because this hasn't been given to you in fx. However, the both represent the derivative. So I write down here as well. First let me finish this one. So then you write dy over dx or dy by dx, whichever you want to say. However, it's exactly the same representation. Okay, let me write down here as well, which you need to remember. The first derivative, which is and dy over dx or dy by dx, these both represent the derivative. Okay, okay, so remember that. So you usually use dy by dx. So usually what will happen, most of the time you will see we will use dy over dx or dy by dx when an expression is given in the form y equal to anything. Okay, so when the y equal to given to, if it's given to you in fx, then you write like this, first derivative like this. If it's given to you in y, then you write like this. Okay, remember that. Okay, so don't get confused with this which one to use and when to use. Right, so move on to the next bit. Here here for all the real value of n, this is what you learned here. Now if it's given to you, right, so if fx is a x to the power n, okay, and as I said, for a constant, so a is your constant here, okay, then what will be the derivative? So the, or you can say first derivative, that will be your a is already here. Now is exactly the same here. You need to bring whatever the value of n, so it's gonna be a, okay, so that's multiply sign, multiply in between, a n x to the power a x to the power n minus 1. Okay, so if you really see difference between here and here, you already have a, so you leave a here, which is your constant, you leave constant here. Okay, so this is what we have done, leave as it is. However, change the x to the power n, and then you bring that one here, exactly the same as what you done here. Okay, so it's pretty simple, right? Because then we will do some examples as well. Then again, same thing. If it has been given to you in the form of y, okay, as explained to you here, okay, if you say that y is equal to x to the power n, then you have your dy by dx equal to exactly the same a n x to the power n minus 1. Okay, so the power here is just reduced by minus 1. Right, so these are the forms. Now let's do some examples or some exercise as well. Okay, because that's what you need to learn. You need to remember this because you won't be given in exam. You need to remember that, or you need to remember the method. Otherwise, it will be pretty difficult for you to solve or to do the differentiation. Right, so let's start then. Okay, start with a pretty simple one. So let's say find the derivative. Okay, so now find the derivatives. Now this here has been given to you in fx. Okay, so find the derivative, the first derivative, when your fx equals, okay, so what that would be. Let me just split this first for you, not to get confused with this one here. Okay, so okay, let's start with a pretty simple one. So let's say if you have fx equal to x to the power 6. Okay, so here f to the power 6, so you have this one here. Okay, so you have fx here is equal to x to the power n, and what will be the derivative of that? N. Okay, so multiply the power, okay, then subtract 1 from the power. Okay, so just remember that. So you got n x and minus 1. Okay, so what we have done here, multiply by the power, okay, and then subtract subtract 1 from the power. Okay, pretty simple. So what we would write here then, so your derivative would be, or the first derivative, that would be your 6. Let's multiply. You got x here, and you got 6 minus 1. Okay, multiply by the power, then subtract 1 from the power. This is what exactly we done here, and that will give us what? It will give us 6 x to the power 5. Okay, so that's your derivative. Okay, so that's your first derivative, right? These are obviously a pretty simple one. Okay, so let's get an example as well. This is where you have fx equal to, so this time your power is half. Okay, fx power is your half. Okay, as long you understand how you have studied that when you multiply the powers and things like that, then there will be no problem, or minusing the power with some other number. Okay, then shouldn't be any problem, and you have studied that. Okay, so it shouldn't be a problem. So now let's sort out this one exactly the same way what we have done here. Okay, because whatever is here is n. This is your n. Okay, so how would you sort this one? So let's say derivative of that would be, so you got half here, so you okay, straight away half, multiply by the powers, the power is your half, and then you got here x. Okay, and then subtract 1 from the power, subtract 1 from the power. Now you need to solve this, right? Okay, so let's do it here for you. Okay, right, so that will give you minus half. Okay, that's, I hope you understand that. Now, so once you have this, what we will write here, half x to the power minus half. Okay, now you can leave like this, or you can go for the next step as well. Yeah, because that exactly means what your square root. Okay, if you have a power of that one, you know that means square root of that as well. However, it's in the minus, so you can write here. Okay, as you know, that can be written as this as well. Yeah, or sometime when you have like this, you can write like this, or whichever way, both exactly the same. Okay, so this is what your answer is. Okay, so let's do another one as well. If you have given fx, this time you have given, let's say, x squared and multiply by x cubed. Okay, now one thing you have to really understand this while differentiating. Okay, you will be given any form. Now you need to bring these exactly the form where you can apply the rules. Okay, so before you apply rules, you need to do a bit of your algebra first. Okay, so you need to be good in that. Once is that done, then you apply rules. Okay, you cannot, sometimes you cannot really do straight away there and then. You have to simplify first. So let's simplify for this one first. What exactly this means? You add the powers, okay? So then you got here x to the power 5, okay? So your fx, x to the power 5, then you will apply these rules, right? Okay, so what will be the derivative? So the derivative would be here your 5, same thing, multiply by the power, subtract 1 from the power. Okay. Now, this is when it's been given to you in fx, as we said, as I said, explained to you earlier, that two ways of representing, okay, this way and this way, okay, and the both represent the derivative, okay. Now let's say if they ask you, I just wanted to do one more example here, okay, that's a pretty good one. So let me do this one here for you. Okay, so let's say if fx is equal to x, however, divide by x to the power 5. Okay, as I said to you, that you need to simplify that first before apply rules. So in this one, as you know, you use the laws of indices to simplify the fraction. Okay, so you must be good in these things, simplifying the fraction or use the laws of indices. So here, as you know, that you got here x, which means that it has a power 1. Then you divide that by x to the power 5, and this can be written as 1 minus 5. Okay, therefore you will have x to the power minus 4. Clear that? Okay, pretty simple. Now once you have that, you write down here, you come here and you say, okay, fx, however, fx is equal to x to the minus 4. So your derivative would be same thing. This time is minus 4. Okay, so multiply by the power, so your power is minus 4. You write down minus 4, and then you say subtract 1 from the power. Subtract 1 from the power. Yeah. Okay. However, as you know, minus 4 minus 1, that is your minus 5. Yeah. And if you want to write, you can also write like this. Okay. Right? Okay. Now, just gonna move on to the another way of representing derivative. So this can be asked you as well. Find dy by dx or dy over dx when y equals. Okay, so what y equals would be. So go with the pretty simple one first. So then let's say you have 7 So your y is equal to 7x cube. So what that would be your differentiation. So derivative, that will be dy by dx. So representing that, now you have to write down this in the derivative form. So that will be 7 multiply 3. Okay, so multiply by the power, then you write x again here, you have 3 here, and then subtract 1 from the power, subtract 1 from the power. Okay, what that would be then? So that will be equal to, you multiply this, that gives you 21 x, you do this. Okay, so use the rule of differentiating. Again, I said, what was the rule of here? When y is equal to a x to the power n. Yeah, that was the rule of differentiating, where you have here a equal to 7. Yeah, and n equal to 3. Okay, right? Okay, so let's take another one as well. This time you have y equal to 3x to the power minus 2. Okay, now again same thing, as long as you remember that 3 is your what here. So use again rule of differentiating. Okay, where you have a x to the power n. Okay, what is your a here? So a here is your 3. Yeah, and n is equal to your minus 2. Okay, and when you do this, when your y is equal to ax to the power n, yeah, then remember I explained to you before, then your dy by dx, that will be your equal to a n x n minus 1. Okay, and because it's the same form, we will use this form as well. Okay, so use this form here, dy over dx. Okay, so that will be your, you already have 3 here, then you multiply power, which is minus 2, x minus 2 minus 1. Okay, multiply by the power, then subtract 1 from the power. Remember always. So always remember that you multiply that one, that will give you minus 6. Then you got x here, minus 2 minus 1 is minus 3. Okay, and if you want to simplify further, then you can write minus 6. As you know, this can be written as 1 over, okay, 1 over x cube. So the answer would be minus 6 over x cube. That is your answer. Okay, so let's take a fewer example. Let's say this time if you have y equal to 8 x to the power 7, and then you also have 3x. Okay, Before you apply the rules, derivative rules, I always say that you simplify first. Okay, so where the expression in the form, so you need to bring this in the form. So you have to bring in this form, okay, before you apply the rule. Okay, remember, a can be any number, and thus including factors. Okay, so how would you do that? Okay, so 8 over 3, you just leave that as it is. Okay, you just have to deal with this, okay, before you apply your derivative. Okay, so use this one here. So what you do, you have this here. Think of that first. Okay, just if you leave that number, if you leave a here and just simplify this first, what would you get? Okay, again I would say to you that you use the law of indices to simplify the fraction, okay, which I used before. Okay, so what will have happen in that case? You have your you can be written as x to the power, okay, and then you can say minus, this is 1, yeah, x, this is power 1 here, so you can say this here, right, and that can be written as x to the power 6, right? So now you know you got this in this form, yeah, so this can be written as your 8 by 3, 8 over 3 x to the power 6, right? Okay, so let me just write down here for you as well. Sorry, it won't be. Okay, let's say y equal to, okay, let's write down this x to the power 6. Okay, so we simplified that and we got this here, right? Now again same thing, multiply the power, then subtract 1 from the power. So you got here 6, so you can write down 6 here. You already have 8 over 3, and then you got here x, you got 6 here, okay, minus 1, yeah, and that you simplify that, okay, whatever it is, it will give you 16x to the power 5. So dy by dx, that is your 16x to the power 5. Okay, right, right, let's take another example here. Okay, let's say if you have y equal to square root of 36 and x cube. Okay, so you simplify that first before you apply rules. So you can write this as square root of 36 multiply square root of x cube, okay, and then you can write this expression as the square root of 36 is 6, okay, multiply, you have here x cube here, and then square root, this can be written as the power half, okay, the square root can be written as like this. You simplify that, okay, as you know from your use the law of indices, so use the laws of indices, okay, to simplify this. So if you have this, as you have, if you have n x to the power n, and then you have another power that's m, exactly the same as here, what you do, these powers you multiply. Okay, so then you have n m. Okay, write down that nm, which means that n multiply m. Okay, so we're going to do exactly the same thing here as well to simplify that. So that will be your 6, 3, okay, 3 and half, then it will be x power 3 over 2, 3 by 2, okay, 3 over 2. All right, so we got this. So we simplified this now. So now we have this y, and that is equal to 6 x to the power 3 over 2. Okay, so we got that, right? Once you have this, you can apply the rules. Dy over dx, that is your 6, your power is 3 over 2, then you got x, your power is 3 over 2 minus 1. Okay, that will be equal to what? Okay, right, and that will be equal to 9 x to the power half, or you can say 9 square root of x, right? Now let's take one good example. Okay, I hope I can complete in this square if I have the space I have left with. Okay, so let's say so you find your derivative dy by dx when the y is equal to, okay, so let's take this example. So simplify this. First we need to simplify before we apply the rule. So that's your 5x to the power 4 multiply 10x, and then you got 2x squared. Okay, so in exam you will get something like this. All right, so you have to get used to solve this, simplify this first. As I said, your algebra, simplify things, factors and things like that, you need to be good at this before you apply this differentiation rules, or okay, otherwise you'll be struggling. Right, so we have got this one here. So before we apply a rule, so what we need to do, we need to simplify this. Okay, so let's do this first, because this can be written. Okay, so we can say, okay, we got here, we can individually take this. Okay, so best way of doing it, think as individually. You have square root of on this one, you square root of, so you have 3 things to deal with there, and you have to do the square root of that and square root of that and square root of that, simple like that. Okay, so let's say if I can say to you, okay, you can write this like square root of okay, and then you can say square root of okay, then you will see you have to deal with this individually. Okay, so let's do one by one so that you understand. Let's do the some rough idea here. Okay, so this expression here, Okay, so take this one first here. You got here square root of 5x to the power 4. So square root of 5 we can leave like this, yeah, and then square root of 4 we can say, because square root is half 4, so the 4 can divide by, so by 2, yeah. So this can be, we can write this as, yeah, solve this, and we can say, okay, we got here square root of 5, okay, and then you got here x squared. Okay, let's do this. This will be pretty simple. There's nothing much to do. You can say here like, okay, square root of 10, and then here is then you multiply this x, and you can say, okay, square root of x means x to the power half. Okay, and let's deal with this one now. So you can say, okay, square root of 2, this is x square, okay, x square, and then square root. So that will be what? 2 over 2, 1. Okay, so that can be written as like what? X. Okay, so that's x. So you can say square root of 2 and then x. Okay, so you see, we simplified this one here. We usually x forms. Okay, so simplify square root, we just simplified this one. Okay, by you just simplified that by using your laws of indices, just to simplify that. Okay, so we simplified this one. Okay, so you can say, we can write this y equal to, here I can, okay, if you say, I can write down here, say square root of 5, okay, and then it was x square. So let's for time being, we leave the x square, and let's bring this one here. Then you have multiply square root of 10. Okay, so what we have from here, x square, and with the square root of 10 here, we have here half. So we can say, we can write x square multiply x to the power half. Okay, so x square, I got it from here. Okay, square root of 5 x, or rather than I'm writing together, I can multiply. I just wanted to bring square root of 10 of this here, so that, because we have to simplify this, then x square from here, and then x to s square root of x, or x to the power half, whichever I want to say, I got it from here. Okay, then what is here? You got here square root of 2, and then you had here x, so that is your x. Okay, clear so far? Let's do one more, simplify one more time. Square root of 5 here, multiply. I can write square root of 10. I can say square root of 5 multiply square root of 2. Yeah, I can do that. Okay, and then I can say your x square multiply x half. So what that would be, so you have here, that will be you adding that one, so you have your x 2 plus half. Okay, and you see that can be written as x to the power 5 by 2. Okay, that's pretty simple. Okay, same thing as we done up there. So you got that. So this can be written as x to the power 5/2. Clear so far? And then you have here your square root 2 and you have your x here. So we still go like this. Your x here power has a power 1, right? So the reason I simplify this way, because I want to cancel this out. Okay, so square root of 2 could be cancelled by the square root of 2 here. Now you got, what would you get here now? You have your square root of 5 and square root of 5. That will give you square root of 25. Okay. Then you have your x to the power 5/2 and you still have your x here. Okay. Further simplify that one. Y, okay, equal to, you just deal with this, yeah, square root of 25, that is your 5, multiply x to the power 5/2. This can be written as x to the power minus 1, and that can be written as 5 x to the power 3/2. Okay. So you got this. So now once you have y equal to in the form where you can easily do the derivative. Okay. Now let me get another page because I haven't got this page here. Okay. However, I will just go like this so they can see. Now dy by dx. So now you can apply the rule. Okay. Derivative rule once we have got in this form. Okay. So apply this. That will again same thing. Very simple. Multiply by the power, then subtract 1 from the power. Okay. So you have 5 already here. Multiply the power. This is your power. Okay, x, and then subtract 1 from the power. That's it. So what that would be? That will be your half. Okay. Okay. You can further simplify that as well. Now you can say that's your answer. Okay. So hope you understand this. Okay. So for today, that's it. Now do me a favor, if you're finding this video informative, please like and subscribe this video. And be sure to click that like button and drop a comment if you have any question. And I will do my best to reply. All right. So for this time, thank you.